Going to look at how to use Desmos to access some of the statistics in the CPM curriculum. And we're going to start with Chapter 10. Now, students need to have an understanding of how box plots and histograms are created. They may have come to that understanding in 10.1.2 with the 40 holes of golf. However, if they have not, it's kind of tricky to do all of that data. They may want to do this problem over here, this first one, by hand, and then use the technology in Desmos to create it in there so that they can kind of compare the two procedures, both by hand and on Desmos. But 1043 is the first time they're really creating the box plots and histograms, and it says on a calculator. And so we can use Desmos to do that. So there's a couple of shortcuts that you may want to do, and the copy paste button works really well if you have a list of data. So here you have your Desmos. It looks just like a regular grid. And then you're going to want to make a set of things. And in this case, we're comparing these two procedures from the time 911 was called to the time that the paramedics reported the bleeding stopped. So they're looking at two different procedures, C2 and C7, and you can actually name them that in Desmos and use a capital letter to name them, and then you can just type the two and it will automatically become a subscript. And then you type in equals, and then you use the square bracket here, and then just copy and paste. And then you could do that also for C7. And then Desmos allows you to do all kinds of things with this data. So now we have these two elements, and we want a combination histogram and box plot. And this says modified box plot, so Desmos doesn't include the outliers. There are ways you can calculate them, but doesn't include the outliers. So we can go ahead and type in box plot and lowercase b for box plot, and then parenthesis. And notice this isn't a square parenthesis. So this, and then just C2, capital C2. So the offset and the height, you can change those things if you want the height to be a little bit higher, depending on how tall you want the boxes. So for right now, height of 1 looks okay, and we want it to be offset. Let's put it up a little bit just so that we can put the histogram underneath. I'm not quite sure where that histogram is going to go, how many values in there, but that should be enough for that one. And then box plot C7. And we'll go ahead and move that up as well. Maybe even higher if we want. And then we can go ahead and do the histogram. And same thing. And you really want to check out your X and Y axis so that you can make sure you're including everything. And sometimes you'll need to change your X axis, like if these numbers were very large and you wouldn't want to just zoom out. And you just click this little wrench here, and then you can decide how far you want to go on your X axis. And I'm not sure, it looks like our largest value over here is 29, so maybe we want to go to 32. So that we can see all of the different values in there. And then our x-axis, we don't need it to go all the way to 10, so we can change that as well. Let's just put 9. And then we don't need to be in the negatives here. So maybe 1. A little bit more. So then we can go ahead and do the histogram. C7. And now we can click and unclick our histograms and box plots, and we can change the color too. So we could change this to match. All you have to do is click on this, and you can change the color. And then let's go ahead and change this one to, we'll leave it at black. And as you click and unclick, you can see underneath kind of what's going on here. Now, in order to calculate all of the outliers, you can actually look at a dot plot. That's really helpful for that if you're just eyeballing them. So you can type in dot plot. You can see probably the red, which is our C7, doesn't have a whole lot of outliers or any outliers in there. But our green one, let's change this to either green or black. Well, let's leave it black. So our black one looks like it does have some outliers. So we can look at those like this, and that shows a little bit where the dots are. The bin width you can change, and the bin width is usually based on how many data values there are, and then you take the square root for what the bin width would likely be. So in this case, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So either a bin width of 4 or 5. So we can change the bin width. So that we can see a little bit better. So with our dot plots, with our dots, we can see this. We can actually calculate it by looking at the interquartile range. And when we look at these two graphs, let's just take the histograms out for a little bit. If we look at these two graphs, we can see that in this one especially, we're going to want to use the median and not the mean as a measure of center because of these outliers. So these outliers will be pulling the mean this way and give us not a good comparison for measures of center. So when we're comparing our centers, we want to use median. And when we use median in order to compare how the range is looking, we want to look at the interquartile range and not the standard deviation. So when we compare spread, we're going to be using IQR. Now Desmos doesn't have IQR built into it, but it does have the quartiles. And all you have to do is type in quartile, and then whatever data set you're looking at, so C2, and then say we want quartile 3. And it'll give you your quartiles. And if you want to, you can actually type in an equation to calculate your interquartile range. So quartile 3 minus quartile 1, and that gives you your IQR. So that's how you can get the IQR for different graphs. And then once you have that, if you wanted to calculate the outliers or where the outliers would be, you can just multiply this by 1.5. So 150% of that quartile range. We have this 8.25, and then when we have that, we want to add that to quartile 1 and add that to quartile 3 and subtract it from quartile 1. So we could take that whole thing and say quartile 1 quartile 3 so anything over 18.25, that's going to be an outlier. And we can actually even graph that if we wanted to. We could say x equals 18.25. And we could see anything over that is going to be an outlier. Now this right here, this definite calculation of outliers isn't a standard and integrated one. That's just so that you can see if you wanted to know exactly where those outliers are. And then you would do the same thing on the other side. It doesn't look like any of these are going to be outliers, but you would take 8.25, 8 and 2500ths, and you would subtract it from quartile 1, and that would be your boundary line as to whether it is an outlier or not. And so when you're comparing, you can use those histograms to compare. Let's get rid of the dot plot. histograms and box plots to compare kind of what that spread looks like. You can see the spread is much greater in our procedure number 7, but we can also compare using different commands the medians. So the median of C2 is 6, and that's 6 minutes in this case, and then the median of C7 is 10. So when you're looking and comparing, you can use all sorts of commands on Desmos as well. This is an example of the statistics functions you can use. When you're finding the standard deviation, if you have the entire population, it's not just a sample, that's why you put that P there. And this X dash 1, that would just be where your C sub 2 would go in there. So you can find the min, the max, the median, the mean, the total, all kinds of things you can do with statistics on Desmos. And so then you'll move on to 44. And in 44, you can actually copy and paste this resource page into Desmos. So let's start a new graph. And you can just click on the resource page and it will pull up this data, and you can actually just copy it and paste it in here. And so what they're doing here is comparing someone else's, let's call it G for golf. They're comparing someone else's 40 holes of golf data to their own. And so they will have to type in their own data in the other box. So that will take them a little bit longer, but at least with this data, they can copy it from the resource page and then it'll just automatically end up in there. And if it has this double bracket, it won't work. So you gotta undo that. Now here you can see that it goes all the way to 269. So you're gonna have to change your scale here. So if we wanted to do a box plot of G, it's gonna be way off the page. So you're gonna need to change this. And our x-axis, let's go to 270. And, oops, 270. And then our y-axis, we don't need to be quite so negative. And then I don't think we're going to need to go beyond 12, but let's go ahead and look at our histogram. And for our histogram, since we have 40, the square root of 40 is around 6-ish. So our bin width is not going to be 1. Let's change it to 6. And then let's offset the box plot a little bit. Let's put it up at 9. So we can see it. And let's go ahead and change the colors to match. Okay, so this is the given data from the 40 holes of golf, and then they would graph their own data to compare, and it looks like I'm a little off right here. You can't see that. So let's change that scale a little bit. Oh, I want to center left. We center left because that's the way our book does as far as checking it. And so if it were right on the borderline, like at 150, the 150 wouldn't go in the bin width from here to here, from the whatever 6 is minus that. So it wouldn't go from 144 to 150, it would go in the 150 bin. That's what that left center does. So let's change this just a little bit. There we go. So now we can see the full picture. And if you want students to label the axes, it's really easy to do. They can just type it in right here. So they can type in distance in centimeters, and then really understanding what this y-axis means in terms of the histogram, not in terms of the box plot. So that's a little bit tricky, but in terms of the histogram, it's just the frequency. And then you can space if you want to move that frequency down. And so in this way, then they can graph their own data and they can graph the given data very quickly, much more so than by hand. And so this is a great tool for them to be able to access that. And then they can access it throughout the chapter as they are given different techniques. One of the standards is to be able to do this with technology, and Desmos is a really great way to do it.